Hello everyone, welcome to my channel. Today we are discussing first two lead code contest question, weekly contest, 338. So let's start with the first question. The k item with maximum sum. There is a bag that consists of item. Each item has a number 0, 1 or -1, okay, written on it. You are given initially non-negative integers, nums 1, nums 0, nums negative ones and k, okay. Bag initially contained nums of item 1, okay. What it really means, bag contains nums of 1 that are positive ones, nums of 0 that are 0, and nums of negative 1 means negative ones in that particular bag. And you want to pick exactly k item among the available items, return the maximum possible sum of the number written on the item, okay. So what it really means, there is a array which contains nums of 1 positive ones, nums of 0 zeros, and nums of negative ones as negative ones, and you need to give them uh, the sum of maximum, what you can say, the maximum number of key element from that array, okay. So you will easily do this using a while loop, where you are going to traverse over that particular three numbers, and the given constraints say k always will be less than or equal to their sum. So you will be going to your first priority will be adding the ones, then zeros, and then -1, and that's you can give the answer such as this, okay. So here is the x sum, that will be total sum, and here while k is not equivalent to 0, if there is 1 is not equivalent to 0, positive 1, then simply decrease its count and add it to the solution. If it equivalent to 0, then check the 0 count. If 0 count is not equivalent to 0, then just decrease and continue till k is not equivalent to 0, and then similar from -1, and then we return the x sum, that will be maximum, okay. So it will be accepted. uh, yeah, it is accepted. Let's move toward the second question, that is really interesting, okay. The second question, you are given a zero index array, the prime subtraction operation, okay. You're given a zero index array, nums of length n, you can perform the following operation as many times as you want. Pick an index that you haven't picked before and a prime strictly less than nums of I, and subtract p from nums of I. Return true if we can make nums are strictly increasing using the above operation, and false otherwise, okay. So what it really means, you need to find a prime number p and subtract it from that nums of I, and do this on all over the nums, and if you are able to make nums sorted, oh, there is one important thing, that you will be able to subtract a particular prime number which is less than that particular number nums of I only one time, okay. So that will be a observable thing here. So you have to do one operation on every element of the array, that's subtracting a prime number from it that is less than it, and check whether it is possible to make the nums strictly increasing or not, okay. So how will we do, let's see the constraint first, okay. Constraint said length will be 10 to the power 3, and almost a number can be of 10 to the power 3 power, okay. So what you can really do, you just have to vector of prime numbers till 1000, then you will be going to find that particular number, what you can say, that the lower bound of that particular number, if there is a, here is given example as 4, 9 and 10, the lower bound of 4 must be 2, okay. So you will be going to find, no, lower bound of the 3 must be 3, lower bound of 4 must be 3. 3 is a prime number. So you will be going to find that roll bound, and you will be having that particular vector of primes in which you are going to find that particular lower bound of this particular index element. And you will be just going to try to minus a particular prime number from the current number, that you will be going to get the maximum possible number it can be, means it must be greater than the I minus 1 element. What I minus 1 element will be also prime, will be subtracted from prime numbers, and getting some number there, and you will need to find a number from ith position that after subtracting the prime number from it p, it must be greater than I minus 1 element. So that's what really it's mean. Let's see the code. So here are the prime numbers from 1 to 1000, and you will be going to check how you will going to do. Okay, you will going to traverse from 0 to the length, and if it is not, or it is a first element and the particular element is less than, uh, you need to have a initial array that is already increasing. If a particular element is less than the immense element, it is not a true condition, then we will return false, and we need to find the lower bound of that particular number nums of I in primes. Then finding after that, you will going to traverse reversely in prime that particular index minus 1 to greater than or equal to 0 in possible case, and particular index number must be less than nums of I till that condition. If particular index is equivalent to 0, or its subtraction is greater than the previous one, then we will going to subtract and just break and check whether it is right or not. If it is not, return 0, and at the end you will going to, yeah, it must be sorted because we have checked all the conditions. So that's how you can go for the first two question. First question is seem to be easy. This is a tricky one because of that low bound condition, or what you can say that a particularity of subtraction from a prime that makes you confusing about it, and it is pretty much tricky. Okay, so time complexity of the first question will be in worst case O of k, and for the second question it will be O of n into worst case maybe n square. You can say that in worst case it may be not on n square, you can say that n into almost that 25 into 10 250, what you can say that the size of their primes. That's what it is. In worst case, it will not cross that, I think so. But almost there, of n into 250, around something. So it will be like this. Thank you. Please make sure to like, share, and subscribe.